Well, welcome everybody. This is Tim Chambers and I am Don Mitchell. Between the two of us, you're looking at 50 years, over 50 years of working in data centers and mission critical environments. Most recently, Tim is the CEO and founder of coolDC and has put to practice many exceptional leadership roles in environment, hybrid edge data centers. Recently received an award from Data Center Dynamics for Energy Smart. My role most recently is with Vitaulic is enabling the liquid distribution in and around data centers in a very mission critical fashion. So moving on from there, let's start with today's topic. And one of the challenges at many data center meetings is, what is the data center of the future? Will it be air cooled? Will it be how big, how small? Is it capable of meeting all demands? There's no singular answer. As we're going to talk about briefly, you're going to have cloud, colo, and edge continue to grow. And it's such a large industry that even a small wedge of that pie will be a large business model in of itself. As you look through these aspects here, scale, how big is the data center going to be of the future? You're going to continue to have hyperscale or data centers that take 40, 50 megawatt as modules and maybe grow to a couple hundred megawatts. But you're also going to be looking at a lot of diversity in physical footprint. The edge is going to continue to grow. There's going to be a lot of racks. Wattage per square foot is a variable. You're still going to have data centers most likely that will be air cooled and will be the more traditional, call it a couple hundred watts per square foot. But as we look at the world of liquids, we've seen models where data center watt densities can be up to several thousand watts per square foot, an unheard of number. And the application you have, the energy usage, the ability to expand our world and the effectiveness of our data center changes accordingly. As we look at energy usage, for example, energy footprint is one of the key concerns of data centers today. The data center industry, prior to a couple months ago, the sustainability aspect was huge. And a term 416 terawatt hours was estimated as the total usage, roughly 3% of the global energy supply. And that was in 2018, was 416 terawatt hours. One of the challenges we have is most people don't understand what a terawatt hour is, but you put tera in front of any metric of energy usage and you end up with terrible. It's just huge. Tim, you have any comments about this?
Yeah, I think the thing we've got to look at is the fact that we've got to go into a more energy usage scenario, where to me the key thing now is, we'll see later, is the carbon footprint is quite crucial now going forward. So let's start using this energy in a positive way, and actually let's try and reuse it.
Fantastic. So we just start looking at, want to talk about that a little bit more on the energy reuse. We'll cover that in another slide. But what about carbon footprint? We started talking about sustainability, Tim, and carbon footprint. What's the relationship there? Sustainability, carbon footprint, data center industry.
Yeah, so if you think from a carbon footprint, one thing we don't want to do, if you take, well, like touch the aviation industry, basically you're creating a carbon footprint during normal running costs. Data centers traditionally do exactly that. What we're trying to do now is, how do we make them carbon neutral? How do we actually use this energy and then reuse it in another way? Let's actually not just throw it away. Let's try and make the energy footprint into a usable energy for another process.
That's a great point. I mean, even if you're using 2% of the world's energy, if you're leaving that available for others to use, the net gain is not a consumption. We'll talk about that a little bit more. So as we look at considerations on this, for consideration to build, as we look at the data center of the future, Tim, why don't you run through some thoughts here?
Yes, I think one of the key things now is the fact that if you're going to look for an energy usage and other ways of using power, the location's more about what's around there. So if you think of something like, traditionally you would build a data center, let's say, out of the way, the view now is, actually, should it not be built near sheltered housing? Should it not be built near an industrial process you could use? If you're going to generate power out there and you're going to generate reuse of loads of heat, Maybe you should be connected to hospitals. Maybe you should use it as a, if you like, as a grid enhancer. So there's lots of ways where the location now becomes a location to work as a data center and also work as an energy center, if that's the right word. The other key thing as well from key to build is what IT equipment is going to be used in there now. Because as you were saying earlier, Dom, is the fact that processors are getting faster and data centers are growing in power. Again, what sort of cooling? What type of technology is going to go in there, and what's the best cooling? Because different types of cooling will be better for the carbon footprint.
Some great review there. Every one of those topics is been a discussion point in data center panels for the past 10 years, but the equation is changing, and just the concept of energy reuse or heat reuse. Stockholm Data Parks was a place because of their cold climate. For example, it is been cited for energy reuse. But we're going to talk a little bit more about, as we get through this a little bit more, about it doesn't always have to be geographic. We actually are seeing some things where liquids enable energy reuse around the world. So Tim, as we've talked about a lot of discussions here about the variation of what's going to happen in terms of densities and the uncertainty of what's going to happen, what's a solution that actually allows, what is the industry using to try to be responsive to adaptability yet speed of deployment to make sure that you don't overbuild and what you end up building as you need? Once you, as you see this slide here.
Yeah, I think the driver now is to actually break down all the areas of data to build. Traditionally, we've always built quite large data centers and put loads of equipment in there. And it's been a bit of a field of dreams. Build and they will come, and hope we pick the right technologies, the right, I suppose, the right size of data center. So going forward, I think what's starting to drive now is modularization, but in all areas, where people will modularize certain areas in the data center. Really, all of data centers that need to be modularized. Because again, it's one of the view that if you've got a site where you can actually use, 2 meg of reuse power, then naturally that's a site you want to start working on, but it's not something that will open and work on day one. So by being able to modularize this and build on in a scale to what the client needs, it allows this to work better. But more importantly, as we were saying earlier, is the fact that the IT is starting to drive what the technology is as well. So if you imagine from a build perspective now, you don't want to build until you know what the technology is in there. What we're finding then is that clients want multiple technologies, not just one. So where a data center was one type of cooling and one type of facility, the view is now that you need this hybrid approach, and you actually build as you grow and as the clients come along.
Interesting. So fantastic discussion. One of the things I'd like to jump back to, this discussion on waste heat and reconceptualizing this. And Tim, why don't you go through this a little thing, and after this we're going to lead into a discussion on energy reuse. But Tim, what is this reconceptualizing waste heat? Tell me about it.
Yes. So if you imagine what we're trying to say here is, if you're on the right hand side, there's different processes of cooling in IT. As you can see from a color-coded view, different types of cooling actually generate, if you like, a warmer waste heat product going to a really hot waste heat product. So what we're saying about reconceptualizing is the waste heat from one process could actually be the, if you like, the input heat of the next process. So rather than looking at the fact that you end up having to split all these processes individually and cool them separately, the idea is you actually think, well, actually, that's actually usable waste product. So if you take something like hot aisle containment, might not be a usable waste product for, say, underfloor heating, it's actually quite a useful starting temperature for things like a rear door cooler. Therefore, you can use that as the feed into there to slowly lift the temperature up.
So interesting, Tim. As you bring this up, you actually raise a lot of passions for me, because I was involved way back when with APC and the launch of a lot of hot aisle containment concepts, which at the time were heresy, and then they became prophecy. I was involved with and tomorrow we're going to talk a little bit more about this, but I was also involved with the green grid. And when they launched that term PUE, They also launched a term called energy reuse factor, but no one really did much with that term. And so for years, I've been looking or very much interested in the concept of energy reuse. And now recently, I've been hearing more and more about that concept. And first with Stockholm Data Parks, I was quite pleased to hear, actually visit places where they're using 40 megawatt energy reuse facilities as part of district heating. But the practicality of whether or not it distributes around the world, Stockholm has an advantage of being a cold climate. But now we're getting to the point, as you point out, as you start looking at the tiering of this, you can actually have cooling of IT with high temperature. And talk a little bit more about how do we get to 60 degrees centigrade, and what does it do for us when we have 60 degrees centigrade heat and opening the door for energy reuse?
Yeah, so the beauty of something like 60 degrees is it's actually on what I would call the usable energy spectrum, where it can be thrown straight into building heating, so comfort heating in building, and the floor heating. This sort of temperature is actually usable. It's not something you have to lift up anymore. So you're actually getting to a point where you're creating something which has actually got a usable value as an energy source, not just as a waste product. Therefore, the key thing is now this waste is actually something you can use elsewhere in buildings, etc., to provide really good services.
Fantastic. I'm kind of driving that home a little bit more. When your waste heat, which a typical air-cooled data center comes out with waste heat in the 30 degree centigrade region, it's really only good in cold climates and for agriculture kind of applications. You hear of a lot of large data centers that are feeding some kind of a farm with a greenhouse or something like that. But when you get to 60 degrees centigrade, now you have something that can be applied even in Arizona. I'm in the United States. 60 degrees centigrade liquid, it ends up being something that could be an asset for certain applications. So the next question ends up being, how do we get that heat out of the building? And the heat goes from your chip somehow out to a heat exchanger. And with liquids, if you have liquids in proximity of the chip, it takes it directly to a heat exchanger. And you might have multiple heat exchangers. Each heat exchanger has its own lift characteristic and the ability to get it out of the building. One of the key things we're going to be talking about tomorrow is the key challenge isn't the components or the technologies. It can be how you plug them together. How do you get one heat exchanger to connect to another heat exchanger in a reliable fashion in an existing data center? And then how do you actually harness the heat that's coming out of that? What can you do with that? Is there a way that you can use heat exchangers and tiering of technologies or cooling technologies to actually do something a little bit better? Say, for example, Tim, you want to talk about here, cooling technologies number one.
Yeah, so what we're saying here is we're actually utilizing cooling technologies matched to IT. But then the important thing here is we actually aggregate temperature to different processes. So what we're effectively doing here is actually going from one side of the data center of a certain technology, which in this case we're showing is hot aisle containment, and we're taking that across different types of cooling infrastructure, which is more appropriate for different types of applications, to end up where we end up with an immersion solution at the end, which is actually fed from all the processes prior to it, which then gives us a lift up temperature, which gives us that usable temperature at the end. Now, if we flick onto the next slide, Don, it shows you how these things actually physically look. So if you imagine, we've all seen the inroads and we've seen the rear door coolers. So these are the things you'll see in traditional data centers for the aisle containment. What you then see next is the idea of actually having liquid physically on board the chips. So you actually load physical elements on there onto the chip, bit of cooling in there, which take the heat straight away, then throw that back into the heat exchanger. What you then see at the end is the bath, where you physically change the view of a rack and you create a bath which you submerge the IT in. So you're seeing a total difference in how IT is cooled here, but they all have one thing in common, which is the heat exchanger. So by working the heat exchanger in between them all, they can all work together to give you that drive towards carbon neutrality.
Fantastic. It's kind of neat seeing how the waste heat or waste energy of one product becomes the inlet and the usable technology for the next. So in your own way, you have this concept of, and what we're going to talk tomorrow about, cascade cooling, where you basically are starting with a waste heat that is of low grade, but you're still able to use that as a cooling medium for the next level up, and so forth, so on and so forth, and in essence get a lot more capacity, and the final outcome ends up being a very high grade heat. So what does it take to do all that to do this? Well, one of the challenges we mentioned earlier is that we still don't know exactly what the data center of the future is going to be. And even when people build a data center, it's in many cases going to have changes over its lifespan. There's going to be density changes. Someone's going to want to walk into a data center and say, let's put a row of high density, let's put a row of low density or air cooled. And so what we're looking at here, the concepts of modular bus bar gives you some flexibility in your power distribution, but there's going to be some limits to that, and that has to take some pre-planning. Just so people know, for years I worked for APC, Schneider, and Eaton, and so I'm very familiar with adaptability and the challenges of adaptability of electrical distribution. And then likely, the other aspect is the sizing and distribution of the fluids. As you transition and try to get that cascade cooling, you're going to need pipe systems that are very adaptable. You're going to need pipe systems that are very reliable, because one thing that will kill the growth of any data center is any kind of a leak in a data center, and that's possibly kept too many people back from trying to use liquids, was the fear of leaking. And tomorrow we'll talk a little bit more about how to make modularity something that's reliable and scalable and adaptable, and aligns with the business model of data centers. Tim, did you have anything else you wanted to put in on this?
Yeah, I think the important thing is, as you say, pre-planning, planning for the future, and showing the flexibility to work on new technologies as the design is built.
Okay, so one of the things that's also of interest is, for years, in fact, back jeepers 2008, I remember going into a lab and seeing a tank of liquid and seeing IT immersed in that tank. And at the time, I was selling in-row coolers for a company called APC, and I took one look at that and I go, I'm going to be out of a job in a couple of years. This is the best way to cool something. Well, that technology hasn't gone away, but Tim, why don't you take it from here in terms of talk a little bit more about what attracted you to immersed cooling? Why did you think it was real?
Yeah, I think the driver for us more than anything from immersed cooling was the fact that we could actually make it part of an existing infrastructure now. Go back to the heat exchanger view, immersed cooling's always been in a cupboard on its own or in a room on its own, and it's separate from the rest of the data center. What we got attracted to is the fact that actually we could add this into it. We could actually make this part of the cooling loop, which then goes back to the important bit, is the fact that the chips are starting to grow now. They're starting to need this sort of product. The end users are getting confident. We've seen it more and more. As you said earlier, we've seen things for a few years now. So it's starting to get there. But the important thing is engineers love it. One of the things which has surprised me is I thought there'd be quite a resistance from the engineering level once you start using it. What we've found in our experience, most engineers, once they play with it, really do enjoy it.
Fantastic. So Tim, now why don't you walk us through, how does this, I mean, the key things with most data centers, power, money, and space, those have always been constraints. How are those constraints changing in the way you're talking here?
Yeah, so I think one of the key things on here to go through, if we go through the three in I suppose the order on the screen, power. One of the drivers always was the fact that wherever a data center was, you had a fixed amount of power. You would get so much power from the grid. Let's say, for instance, it's 2 meg. You then look at your floor place and just divide that by X amount of racks to try and get your revenue through. What we're finding now, as the slide shows over here, is that the chip power use is actually getting more and more. So the power needs to be more flexible. So you've got to be ways of bringing more power in. There's got to be ways of reusing that power to allow all these different chipsets to go. So then we go back to the money argument. The data center needs to be a floating environment rather than a fixed build, because you build something fixed and the new technology then can physically reside. Hence why we've got quite a lot of empty data centers around where they get filled to a certain point, but then they don't need to move. But the other important thing is the fact that data centers were very much about space, the cost of space, the cost of square foot. The issue you've got now, if you put faster and faster processors in, which use more and more power, the rack density increasing. So a 2 meg data center can be a tenth of the size of a 2 meg data center from 5 years ago by using this technology. So the normal view of power, money, and space is now starting to change, where you can get more out of a smaller space, and the costs are dropping for a lot of the IT as well. So the data centers actually becoming a lot more cheaper to build and build on a smaller footprint.
Fantastic. You know, Tim, one of the things I really liked about, or was honored to be able to present with you today, was the fact that you've actually done this. I've worked with a lot of people, a lot of vendors who actually say you can do this, but I'm amazed you've actually done this. Tell me what you've done.
Yeah, I think one of the great things about the Lincoln Discovery Center, or LDC as we like to call it, we wanted to actually show that a data center should be a hybrid living environment based on client requirement. Therefore, the cooling technology needed to be a complete mismatch. We also wanted to show that you could mix and match different types of technologies. So we've got low powered units in there, high powered units. And the other thing we want to do more than anything is show that OCP can reside in a normal data center. You don't need to build an OCP data center. You don't need to build an HPC data. You can build them together. The other important thing about this site, which we definitely went along with, was the fact that we needed to build it within the criteria and the accreditation which proved how efficient the data centers were. So for us, it was all about building in a really efficient way, but actually showing the hybrid design. So we focused very much on CEDAR, which is all about the energy efficiency and the energy reuse. We followed the European Code of Conduct, which again is all about building in set standards in a set way. But what we were very proud of at the end was the fact that we got the Energy Smart Award, because we believe that the data center is becoming an energy center. So at Lincoln, we actually generate our own power. We then take the power up into a nice temperature through the heat generation, and then reuse that heat around the building. So the data center actually becomes like an energy store, which actually physically use it out the way. So rather than just polluting, my view is we want to build this carbon story where we actually become carbon neutral, and Lincoln demonstrates that.
Fantastic. So let's take a little bit more look at what you have here, Tim.
Now, where Lincoln was also really interesting is the fact that we also wanted to change the view of what a data center really looked like. So Lincoln is actually 4 standard offices converted into a data center. Now, we wanted to show that we could build in an existing building, because this new technology using heat exchangers and using things like the immersed cooling means that the data centers become very quiet environments. As you know, Don, from when we started in IT, a data center was a very noisy environment. Yeah. What we're finding now is that technology is allowing this to be really nice and quiet. Because it's nice and quiet, we can build this close to other people. So if you take Lincoln, we've got 2 sales teams above us, and we've got an engineering design team above us who don't even really know there's a data center behind them. Now, what we did there was prove that building standard rooms, that's a data center. There's no false floors, there's no false ceilings. It's just heat exchangers fastened together using different types of technology. And the other important thing is we're now in a building now where we share it with other tenants. So the other thing we want to do, well, actually, there's the perfect use for all the power. Let's reuse it around the building, which is what we do.
Fantastic. The comment about noise is something that's been increasing as temperatures go up. If you try to use air, you have to use more air. And then generally what you end up doing is the newer data centers are much louder if they're air cooled, because they're trying to push a lot of air through the same channels as before. And correspondingly, their efficiencies drop off. And we'll talk a little bit more about that. Tomorrow's topic is going to be managing barbecues in your data center. And we'll talk about that then. But carry this forward a little bit more. What do you have here there, Tim?
Yeah, so one of the things I want to show here is from an OCP perspective, what we wanted to do was we had a client who wanted to use a cloud platform, but he needed identity from an HPC point of view. So what we wanted to show here is the fact that we could use, by working with Ripple, we could actually lift the density of the OCP racks, which is what we do use in their LTP units. What we've also now developed again is we've now actually started to put the actual chipsets within these actually on immersed cooling, as in on chip type, where we actually have little immerse units which physically sit on top of the chips. So we use a two-phase heat recovery system, which gives us even more efficiencies and more direct cooling to the chip. So what we're saying is OCP is very much part of the future of a liquid cooling and a hybrid data center.
Ah, neat. So let's see if I can get this to advance again. So back to the data center of the future, the prerequisites. How about you run through what you're seeing there, Tim?
Yeah, so what we see and what we've hopefully proven with Lincoln is the fact that the scale of the buildings can be smaller, but the power density doesn't relate to the size of the building. So in other words, you can actually build them really high powered if need be, but because of this new technology, it doesn't need to be a massive building. The energy efficiency side for us is all about the fact that this new technology really is energy efficiency in itself. So part of what we can do now by using heat exchange in the right way, mixing things like immersed cooling and on-chip cooling, which really do get the heat out of the chips very efficiently, it then takes it into a temperature range which becomes a facility then to create carbon neutrality for the data center. But we're also finding is the fact that the data center is now at its change point. We all talk about the fact that everybody's old, like me and you, Don. What we're finding now is the younger generation are really excited by getting into this new technology. So the new generation are the people who are driving this all forward, and they're not scared of new technology.
Well, I agree with everything you said, except for I'm getting old, and that's we just got to stop that, Tim. So let's kind of look over here. We're getting close to the end of our presentation. The takeaway lessons learned. What would you like to share here?
The lessons that we did was it's all about monitoring. Monitoring's key. You talk about energy efficiency, you talk about reusing energy, you talk about new technology. The most important thing is you've got to be able to see it and prove that things work. We went through a lot of, I suppose, trial and learn ideas where we were looking at things in different ways. But the most important thing was to make sure that that building management system could actually reflect all the kit what you've got in there. So what we're finding with a lot of this new technology, it didn't actually have the tools of what we're all used to from a data center perspective. So one of the things we did do is we would like to improve on this, but we've worked at the moment on Modbus. I say Modbus a necessity. The reason it is because most of the older technology use Modbus. We've now put Modbus into the new stuff, which means we can measure it really well. And then the next stage, more of anything else, once you start to measure this, your flow and returns between the different heat spots and the cold aisles as you run them all through become really critical. And really, this is where we come back to your side here, Don, where working with manufacturers, understanding exactly what the flow returns are is really crucial. And this is where the management of the pipe system, the planning up front really makes a difference. I'm sure you'd like to tell me.
Well, Tim, appreciate that. And yes, we're going to cover this tomorrow in that discussion on barbecue or managing barbecues in your data center. But to your point, the putting together pipe solutions in a way that maximizes your flow and return per phase, there's can be a trick to that. There's a reason we have engineers that help put that together. And the manufacturer partnership, getting the integration of BIM design, virtual design and construction, creating reference designs that make it simple to plug in and enable these technologies that you're already doing and have your data center grow is going to be an essential dance together as our organizations try to build our future that's going to be measured in decades, not just in a couple years. So we're almost out of time here, but Tim, why don't you summarize your call to action? What is it you want people to, what are you going to close out this year?
Yeah, I think for us, we've now got to look at the hybrid DC as a real facility now. And I think one of the key things we want to do is actually put what the requirements of what an actual hybrid DC really need to be. We're going to update the white paper of the data center of the future to talk how this hybrid system actually becomes a reality. And then finally, the idea is we'll put together a design document so that people can start to look at implementing this sort of new technology within their existing data center and hopefully moving existing facilities into carbon neutrality as well.
So Tim, I think that wraps it up. Very good review. I'd like to remind everyone on the call that a lot of the topics we covered today will be covered a little bit more in detail or from a slightly different perspective in our presentation tomorrow on managing barbecues in your data center. Right now, we'd like to open the floor for question and answers period and an opportunity to discuss. So please have at it.